In this video, we're going to talk about the rational zero test. Now, the rational zero test can also be referred to as the rational root test, or the rational root theorem, or the rational zero theorem. Again, zero and root are theoretically interchangeable, and in this case, test and theorem are sometimes interchangeable. Now, this particular test or theorem allows us to determine what the possible rational zeros of this polynomial happen to be. Again, I'm going to rewrite that as possible rational zeros. Now, the thing to note about rational zeros is there's not going to be any radicals or pi values in them. Rationals could be fractions or whole numbers. These I'm going to refer to as PRZs. PRZs. These end up being a list of specific numbers that could be zeros of this polynomial. So in the previous videos, we talked about, again, the factor theorem, the remainder theorem, long and synthetic division. The question is what values am I going to attempt to divide this thing by in order to find a zero, an actual zero? I can't always be given that what I'm going to divide by is going to be told. So the question is what am I going to attempt to divide this thing by? Well, the possible rational zero, or the rational zero test, specifically states that if I take the factors of the last term, specifically the constant term, and I divide it by the factors of the first term, again the leading term here, that means I'm going to provide myself with every possible rational zero that this polynomial could obtain. So I need to first identify what are the factors of 12, and then I need to identify what are the factors of 4. Notice how I did that first. I said I need to find this last term, what are the factors of that first, and I need to find what are the factors of 4 second. Well, the factors of 12, and I'm going to list them in this way, are 1 and 12. Then 2 and 6. After that, I can go 3 and 4. And you'll notice there's no more in between there. I do it in this order so I don't miss any. And again, my intent is divide 12 by 1, then 12 by 2, then 12 by 3, and then once I get to 4, I've started repeating the pattern going backwards. So those are my only possible values that I can find from 12. We're going to do the same thing with 4. It's 1, 2, and 4. Yes, I know there's technically two 2's there, but we don't need to write both of them. We just need to at least have every possible factor of those terms. Now, to find my PRZs, I can multiply, again, 1 times 12 and get positive 12. But also note that I can multiply a negative 1 by a negative 12 and get a positive 12. So that means that every single one of these numbers here could be positive or negative. Doesn't matter the order what I put them in. I just need to know that there's possible. Which means that if I'm going to take the factors of the last term and I'm divided by the factors of the first term, I'm going to start with 1 and divide it by 1. So plus or minus 1. And again, the reason why that is because 1 divided by 1, I could have this number be a positive or a negative, I could have this number be a positive or negative, and they can, again, cancel each other out to be positive, or not cancel each other out and be negative. Then I'm going to go ahead and do 1 divided by 2, so it's plus or minus 1/2. Then plus or minus 1/4. Again, me taking this number, factors of the last, dividing it by the factors of the first. Okay, then I'm going to move over to the 2. I'm going to do the same exact thing with the 2, so plus or minus 2 over 1, plus or minus 2 over 2, and then plus or minus 2 over 4. Now, there's a little problem with the values that I'm currently picking here, and the fact is that plus or minus 2 over 2 is repeating itself. We do not want to see those repetition values. Again, the intent is for us to create a list of possible factors that we can attempt to divide this thing by. But if I attempt to divide it by it, and I'm doing repeats of numbers, I feel like I'm just wasting time, and we want to avoid that at all costs. So anytime you have a repeat, either A, cross it out, or B, just don't write it. So I'm going to go ahead and continue this pattern. It's plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 3 over 4, and you'll notice none of those are repeats. I'm going to move over here to 4, and that's going to be plus or minus 4 over 1, which I'm just going to rewrite as 4, because I don't really need to see that division by 1. But 4 over 2 is 2, which I already have, and 4 over 4, which is 1, which I already have. So I'm going to skip writing the rest of those. Let's move on to 6. My next one is going to be plus or minus 6, because it's 6 over 1, and then plus or minus 6 over 2, but 6 over 2 is 3, and I already have that. And then 6 over 4 is 3/2, and I already have that. So we're going to skip writing those. And then finally, plus or minus 12. Again, 12 over 2 is 6, and 12 over 4 is 3. I have both 6 and 3, so I don't need to repeat those. So these are the lists of all the possible rational zeros that this function could have. Now, it doesn't mean that it has to have those possible rational zeros. It just means that a couple of these could be zeros of this. They don't have to, But if there are going to be rational zeros, if they're going to be fractions or whole numbers, it has to be from this set of numbers.